Before we leave number 11 behind, I wanted to talk to us a little bit more about what we did at the very end. I want to mention that this portion right here, the do not reject because the test statistic is not lower than the critical value, that is called the classical method. When you compare this number, this test statistic, to this number right here, this critical value. Here, let me highlight them. When you compare the two of those, that's the classical method. Okay. When you compare the p-value, this guy, to this alpha up here at the top, let me put those in green together so you can see. That is called the p-value method. Okay. Now, the p-value method is the method that's preferred in modern times because we have computers to figure out things like the p-value out for us. And the p-value is always compared, always, to alpha, always. The classical method, it's a little bit weirder because if you're doing a left-tailed test like we are in this case, you want to see if this number z right here is lower than this. If you're doing a right-tailed test, you want to see if this number is higher than this. Or if it's a two-tailed test, then either is okay, lower or higher. So that's a little bit weirder than this p-value, this green one, always is less than, always, never changes, never is greater than, never is less, right? It's just less than every time. And you always compare him to alpha, this guy right here. So just to keep in mind, what's the difference? The difference is classical is actually a little bit trickier. It compares test statistic to critical value. P-value method compares p-value to alpha, always. And then another thing I wanted to mention before we left this behind, is that there was a whole other way to do this. Let me click on it. StatCrunch. Remember StatCrunch? So if you wanted to, you could do the problem here. Let me move this over just a bit so you can see what I'm doing. There we go. StatCrunch. Okay, so we would go to Stat, click on that. This is Z statistics because you're doing a Z test. One sample, again, two sample is chapter 11. We're not doing that. So we don't have data. You don't have a column of data. You're looking at summary, so click summary. Our sample mean was 47.1. Our standard deviation was 12. Our sample size was 24. Click next. We want a hypothesis test. The mean is 50 in the hypothesis, and our alternative is a less than, right here, less than. And then click calculate. Let me copy, and I'll go back to my Excel window and paste. Where shall I do it? You know what, I'll do it over here. I'm just going to make this column small again so you can see it. There we go. And I'm going to paste it right here. Now looky. You can see your HO and HA and all that good stuff. Okay. There's the test statistic right there. There's the standard error that we found. There's the p-value, just like we did. So that's another way to do this, a little bit faster. As it often is in StatCrunch, that some things are faster, but you're not seeing the nuts and bolts here. You're just seeing everything magically done for you. And also, of course, sometimes we might need some of these interior portions. All right, so there it is again in StatCrunch. Let's check out DDXL while we're here. I don't think this is possible in DDXL, but let's check. So we would be doing a hypothesis test. We'd be doing a one variable Z test right there. Right, this is no good. Ooh, nope, none of it. All right, so it won't let us do this because it wants a column of data, but we don't have any data to give. So this is not possible. This problem is only doable either with the longhand with Excel or this way with StatCrunch, and those are your options, and that's it. Okay, so that's the end of that problem. I'll see you next time for the next problem. We'll be doing a right-tailed test next time.